Hi class, I guess welcome back, sort of. Nice to be doing something with you guys again here. Say, before we start hitting stuff again, I would thought, let's just take a day here and we'll look at the coronavirus issue from the perspective of some of the stuff that we've already done in here dealing with exponential growth. I saw the headline in the Washington Post here, well, I guess it was on the 17th. And they had this article, and it was kind of almost a question. They said, yeah, I've got it right here, why outbreaks like coronavirus spread exponentially and how to flatten the curve. And the exponentially part, there was sort of a question on there. We're going, oh, is this thing exponential? And people do throw around that word. Anytime things grow quickly, we know that people use the word exponentially, even though it's not always exponential. If you recall, at one point we looked at whether things are linear or quadratic or exponential. That was the ibuprofen lab with the colored water that I did with you guys a while back. Anyway, so I thought, let's take a day here. It's good practice for me to start videoing myself. I have done a little of this before, but not as much as we're going to be doing over the next couple months. And just to maybe take a breather, just look at some mathematics. That's not necessarily the content we're covering right at this moment. So I thought I would take a look at this thing. First thing is about flattening the curve. The question, why do we, that expression flatten the curve? I've got this, you can see here this picture I took off the internet. This is a pretty good explanation of why we're talking about this flattening the curve. It's the idea of, like over here with these matches. You bunch them all together and light one off. They're all going to get lit up real quick. Now, if you spread them out, you're still going to burn just as many matches. They're just going to go one to the next at a slower rate. That's really what this flattening the curve thing is all about. You see, our hospitals and our clinics, they can only handle so many people. And so what we're trying to do is not necessarily keep as many people from being infected with the coronavirus. We're just trying to keep it from all happening at once and overloading the healthcare system. Because if we do that, we know that people aren't going to get to seek the medical attention they need, and people will start to die at a higher rate because they just aren't getting treated. So we're trying to save lives. That's really what we're trying to do here. Try and save lives by spreading us all out. So here we are videoing lessons on the internet. I hope things are going well with you guys. But that's kind of what that's all about. I don't think it's too difficult to figure that part out. But going back to the article about, is it exponential? I thought, well, let's take a look at this. What does it mean to be exponential? Take 2 to the x. We say it's exponential because x is the power. What does that really mean? Well, 2 to the x would just mean, well, it's doubling over and over again. It's times 2 and times 2 and times 2. And how many times did you multiply it times 2? Well, as many times as you want. That's the variable. So exponential. And we've covered this in class. But I just want to address that question that the Washington Post put out there. So what I did is I took the CDC's got on their website how many cases are coming out every day and how many there are. And so I went back and I've got all that data. You can see I've got that data over here. The days that since they started keeping track, the first day they were at 15 and the second day they were at 29 and so forth. And it varies. This is the thing about, we're going to be using statistics here to talk about algebra. Statistics is always messier. It's not nearly as nicely cut as sometimes an algebra class makes it seem to be. So you kind of have to look at this from a about scenario. Well, if it's exponential, then it's multiplying by basically the same thing every time. Think about, again, 2 times 2 is 4 times 2 again is 8 times. Which the way to check is to answer the question, could I divide by approximately the same thing every time? The ratio between the one prior to it and the day that you're looking at. So like, for example, what I've got here, ratio of the previous day. So I just I just took 29 divided by 15, 1.9. 35 divided by 29, 1.2. And I copied that. This is, of course, just using Excel. I copied that down. Gave me a total, and then I divided it by how many. So on average, again, you got to think statistics here. On average, it's being multiplied by about 1.2 every day. And you can see that, you've got some that are lower, you got some that are higher. That's the issue with dealing with statistics. It's not going to be a perfect number every time. That's just not reality. But on average, it's averaging about 1.2 as a multiple day after day after day. So I would say, yeah, this is exponential. You could say y is equal to 1.2 raised to the x power times whatever you started out with. Now, in that article in the newspaper, they actually made a claim. They said, hey, it's doubling about every third day. So I went back to these numbers here, and I just set it up in the document here and divided that out. But I could use this as a model, exponential model. Y is equal to 15, what you started out with, what you're ending with, and how long has it been multiplying by this. It's a lot like that PERT equation we've looked at. But there's a model I could use. If I look at the third day thing, well, then I went back and I divided. I said, okay, every third day I'm going to do that division. And here's what I got there. 2.5, 1.4, so on and so forth. I did the same thing. I added them up and divided, so it was averaging just over 2. So the Washington Post was correct in saying that it's doubling about every 3 days, which of course means it's exponential. And I could set up a model with that. Well, it was 15 on the first day, and it's been just a little more than doubling every day since. So this would be my model for that, my exponential equation. From there, we can look at other things as well, but you need to realize this is following an exponential model right now. It will not continue to follow it forever. This is exponential, sort of. What this does end up being is a bell curve. Eventually, it should be a bell curve. We're down here, we're in the exponential growth part. And if you recall from earlier this year, we did look at that there was other exponential related models, the bell curve being one of them. Here's the nasty formula for it. I'm not going to go into all that with you guys. And then quite frankly, there's things that we don't know what some of these values are yet anyways. But we're in this part right here. Eventually, it should peak out and then start to come down exponentially, whether it's the same rate or not. There's a lot of real-life variables here that make it hard to predict. But we're in this area here. I know that because I know that these numbers are still growing, the ratios, so the rate of change is still changing in a getting larger manner. Up when it gets to be about in here, we'll see these ratios actually start to get smaller. The rate of change will decrease. Then we'll know, hey, we're headed towards the peak here. We're past the growing part so much, headed towards the amount where we're going to hit the top. But we're not there yet. I wouldn't expect it for a while. So I thought I would look at that question. Well, can we use these numbers to predict how long this is going to take? Sort of. I thought, well, we can go through an exercise kind of doing that. The question of when is it going to start heading down? Because at least then we know we're about halfway through it. So I had to look at some numbers first. I call them fact-ish facts. Okay, I don't know if they're facts or not. This is also new that what are the facts? I don't know. They seem to change every day. But one of the numbers that's been thrown out is that about 40% of the population's going to get infected with the coronavirus. Now, I heard a lady from the CDC say eventually everybody will. But on average, it's been infecting 40%. So I don't even know which number to actually use there. So I took the U.S. population, 327 million, and I'm like, okay, well, what's 40% of that? That's all I did. And that's where I got this 130,800,000. Well, from that, halfway. So that would be like everybody that's going to get infected if it stayed at 40%. So let's just see how many to get to there, to the top. And I know it's not exponential the whole time because it's going to start to slow down towards the top. But I took half, And then I just took that little equation for modeling every third day, because that was doubling. Okay, say, well, started with 15. When am I going to get 6,540,000? When I take the 15 times 2.1 raised to the x. So this is the when. This is, how fast is it growing? So I'm dividing by 15 first. And then what I'm going to do here is I'm going to use a logarithm. I've got to solve for an exponent. I need to introduce logarithms. I'm technically going to do the change of base formula. That's what I'm doing here, if you remember the change of base formula. Take the log of each side and divide, and end up with pretty close to 21 days. Now remember, this is for doubling, so it was every third day. So I got to multiply this by 3 still. So that ends up giving us 62, 63, something like that, days to get to the top of the curve. So we're looking at 2 months to get to the top, and then if it was symmetrical, another 2 months to get to the bottom. Now I will be the first to say that, hey, this is probably not correct, because we're trying to flatten the curve, which in doing that, what it's going to do, it'll take longer to get through everything. So my numbers were with an initial population. We're still in this bottom part here. We're trying to flatten it. So there's a lot of variables. If you look at some of the graphs of how it's working out in other countries, these graphs end up being very jagged because they try something, it kind of works, then it goes back to growing. Again, real life isn't always very pretty when it comes to the numbers. But there's my calculation. Like I said, getting to the top about 2 months in. But there were some assumptions here that, like I said, is it going to be 40%? I don't know. Is it exponential? Only for a while. Then it's going to change. So that part of my analysis here isn't going to be correct. And are we able to flatten this at all? They say we're having some success flattening the curve. So I would guess this would end up turning to at least a 3-month thing, which then if you double it, well, it's looking at like a 6-month thing, which isn't good news. We're all getting sick of this already. No pun intended. But at least it gives you maybe some perspective to look at this. There is hope. There's hope that at some point this will all be done. So, like I said, this is my trial run at doing a recording. I have had a lot of people asking me, Mr. Thorson, how long do you think this is going to take? Mr. Thorson, how long do you think this is going to take? Which is kind of why I did this. I was like, well, I can put out a really goofy guess here is what it amounts to, but it's a little bit of an educated guess, but it's still a guess. So there you go. Do with it what you want. Think of it what you want. I will be making other videos for our other topics. I will hope to see you soon.